At 100 times the diameter of Earth and more than 5,000 degrees Celsius at its surface, it's safe to say the Sun is both huge and hot. But what else do we know about its basic anatomy? What lies beneath the Sun's fiery surface? Chemically speaking, the Sun is pretty simple. 91.2% hydrogen, 8.7% helium, with 65 other elements making up just a tiny fraction of the total number of atoms in the Sun. But that's where the simplicity ends.
Well, the Sun's a crazy place, right? It's far too hot to be a solid. We know that. Heat it up, it's far too hot to be a liquid. And so you think, well, it's a gas, right? Well, not really. It is this gaseous soup of charged particles that we call plasma.
The thing is, the composition of this soup of particles is different depending on which part of the Sun you're looking at. Like a complex dessert, the Sun is made up of multiple layers or regions, 6 in all, 3 beneath the visible surface layer and 2 above, and each has its own set of physical and behavioral properties. Peeling back the layers beneath the visible surface, we arrive at the Sun's core. This is the nuclear reactor, where under the crushing force of gravity, hydrogen atoms fuse to form helium. This process releases tremendous amounts of energy, making this by far the hottest part of the Sun, burning at more than 15 million degrees Celsius. Above the core is the radiative zone. As its name implies, energy produced in the core is radiated through this layer, but not as quickly as you might think. On average, it takes more than 100,000 years for a photon, a packet of energy released by the core, to escape the dense radiative zone. Above that is the convective zone, a layer known for the swirling currents of plasma that carry energy from the Sun's interior towards its bubbling surface. Because energy is actively transported by these currents, it takes on average only a month for a photon to move through and out of this region. Which brings us to the visible surface itself, the photosphere. This layer often appears smooth and calm, its only blemish the occasional sunspot. Only the dramatic increase in the number, size, and complexity of these spots would suggest any unrest beneath. Until recently, that's all we knew of the Sun, the visible surface and the theoretical models of its interior. But now that we can see the Sun in high-frequency wavelengths of light, 2 more regions, the chromosphere and the corona, have revealed themselves. These layers, which collectively make up the Sun's atmosphere, burn far hotter than its surface. In the case of the corona, about 1.6 million degrees Celsius. Now that we can finally see these layers, they tell us more about what goes on inside the Sun than we ever knew before. And they hold the key to understanding and predicting violent solar storms.